Israel may be closer than anyone expected to doing something air forces have been dreaming about for decades, putting a practical combat laser on a fighter jet. That matters because the hardest part of airborne laser weapons was never writing the concept on a slide. It was shrinking the system enough, cooling it enough, stabilizing it enough, and aiming it precisely enough to work on an aircraft that is vibrating, maneuvering, and fighting in real weather. According to reporting based on Elbit Systems' 2025 results presentation, the company now says it has overcome those classic barriers and already has a contract from Israel's Ministry of Defense to develop high-power laser systems for fighter aircraft and helicopters. In Elbit's own presentation, the fixed-wing version appeared under the name Excalibur, while the helicopter version was shown as Sting. This is why it is no longer just a futuristic concept. It's a real military program. To understand why this matters, you have to start on the ground, not in the sky. Israel has spent years developing laser-based air defense, and by May 2025, the Israeli Ministry of Defense, the Israeli Air Force, and Rafael said high-powered laser systems had already intercepted scores of enemy threats in wartime for the first time. By December 2025, the first operational Iron Beam system had been formally delivered to the IDF. Rafael describes Iron Beam as a 100 kilowatt class high-energy laser designed to neutralize rockets, mortars, artillery threats, and UAVs from hundreds of meters to several kilometers away, with almost zero cost per interception and an effectively unlimited magazine, as long as electrical power is available. But Iron Beam also shows the limits of staying on the ground. Ground-based lasers are constrained by line of sight and by the lower atmosphere, where dust, humidity, rain, haze, and turbulence all complicate beam performance. That is exactly why Elbit CEO argued that an airborne laser has a major advantage. The higher you go, the less the beam is affected by those conditions, and the more likely it is you can engage threats above cloud cover and farther from the target you are trying to protect. In plain language, Israel is trying to move the laser from the last line of defense to an earlier line of defense. Instead of waiting for threats to get close, aircraft with lasers could potentially attack them sooner, with a better angle, and without burning through expensive missile stocks. The first likely host for such a weapon is the Israeli F-15I RAM, and even more importantly, the future F-15IA. The official Israeli Air Force data gives the F-15I a maximum speed of Mach 2.5 and a range of about 2,760 miles. Boeing's current F-15EX line, which is widely seen as the closest baseline for the future F-15IA, is listed at 81,000 pounds maximum takeoff weight, 29,500 pounds of payload, and Mach 2.5 maximum speed. Israel's 2024 order for 25 F-15IA aircraft is especially important in this context. These jets are expected to feature greater range, higher payload capacity, and the integration of Israeli systems, with deliveries beginning in 2031. For an airborne laser, that is a powerful combination. A large twin-engine aircraft with enormous payload margin and long range is simply the easiest kind of fighter to turn into a laser carrier. If Israel wants a serious laser truck that can patrol, escort, and engage drones or missiles at standoff range, the F-15 family makes the most sense. The second very plausible option is the F-16I Suva. Israel's Air Force lists the F-16I at about 48.9 feet long with a 2.8-foot wingspan, a top speed of over Mach 2, an empty weight of about 22,000 pounds, and a maximum takeoff weight of roughly 51,800 pounds. Compared with the F-15, the F-16I is smaller, tighter on internal volume, and less comfortable as a host for a larger power and cooling burden. But it also offers a different advantage. It is a more compact and widely usable platform for an airborne laser that is meant to kill drones, cruise missile class threats, or smaller aerial targets rather than carry the biggest possible beam. In other words, the F-15 looks like the premium host, while the F-16I looks like the more distributed operational workhorse. The F-35I Adir is the most glamorous possibility, but probably not the easiest first step. Lockheed Martin lists the F-35A baseline at Mach 1.6 with a combat radius of more than 680 miles on internal fuel, and Israel has been flying the F-35I operationally since the late 2010s. The problem is obvious. The F-35's main advantage is not just being modern, it is preserving stealth through clean external geometry. A visible laser pod under the aircraft would introduce serious trade-offs for the very jet whose strength is low observability. That does not mean the F-35I will never carry a laser. It means the F-35 is probably a later, more specialized path, while the F-15 and F-16 are the more practical starting points for Israel's first operational airborne laser effort. On the helicopter side, the logic changes. Elbit's contract also covers helicopters, and the company presentation showed the Sting concept for rotary wing aircraft. A helicopter laser would not be about high-speed patrol over huge distances. It would be about persistent line-of-sight defense, protecting specific corridors or assets, and engaging slower aerial threats at tactically useful ranges. It would also face tougher stabilization and survivability challenges than a fast jet, so the helicopter version is not the glamorous headline. It is the practical lower altitude layer. So how effective could Israeli laser-armed aircraft actually be? Against the right targets, very effective. Everything public about Iron Beam points towards drones, rockets, mortars, cruise missile-like threats, and other relatively small aerial targets as the ideal target set. Elbit's concept material also showed the airborne laser destroying a missile and a Shahed-like one-way attack drone. That makes sense. A laser is not competing with a fighter's radar-guided missile in the classic air-to-air role. It is competing in the world of repetitive, low-cost interception against targets that are dangerous mainly because they arrive in numbers. If Israel can put such a weapon on aircraft, the real payoff is not cinematic destruction. It is changing the economics of air defense. A laser shot powered by onboard electricity is fundamentally different from spending one expensive missile after another against cheap drones. That does not make the system magical. A fighter-mounted laser still needs enough dwell time on target. It still needs precision tracking. It still depends on atmospheric conditions, even if those conditions are better at altitude than near the ground. And the real combat cost is more complicated than the phrase sense of electricity. The aircraft itself is expensive. The pod will be expensive. Maintenance, thermal management, battle damage tolerance, and mission networking all matter. Even the program cost remains undisclosed. So the honest way to frame this is not lasers replace missiles. It is lasers may become a new reusable layer for defeating drones and similar threats before they can force you to spend missiles. That's a very different and much more realistic claim. The United States has tried to reach this point before, and that history explains why Israel's progress is getting so much attention. America once built the massive YAL-1 airborne laser, a modified Boeing 747 carrying a megawatt-class chemical laser for boost phase missile defense. The aircraft did achieve a major milestone. U.S. Air Force historical material says the high-energy laser intercepted a test target in January 2010 and then successfully destroyed 2 test missiles in the following month. But the concept was far too large, too costly, and too specialized to become a practical combat fleet system. The YAL-1 proved that an airborne laser could work. It did not prove that it could work in a way air forces could actually afford and deploy at scale. After that came a more relevant effort, SHIELD, the Air Force Research Laboratory's podded laser for tactical aircraft. AFRL described SHIELD as a directed energy system designed to reside in an aircraft pod and demonstrate defensive capability against surface-to-air and air-to-air missiles. That was exactly the kind of miniaturized fighter laser path many people had imagined, but the program never matured into the operational breakthrough once hoped for. The United States also tried to put the airborne high-energy laser on the AC-130J, And that plan was canceled after technical challenges delayed the integration past the aircraft's flight test window. In other words, the U.S. experience proved the concept in pieces, but struggled to make it routine and deployable. And that is why Israel's project feels different. Israel is not beginning with a giant science project. It is beginning after years of laser work, after real wartime interceptions by ground-based systems, and with a clear tactical problem driving the effort: the need to stop drones and missiles without exhausting missile stocks. That does not guarantee success. Israel still has to prove beam control, thermal management, pod integration, and operational usefulness on real aircraft. It also has to prove which aircraft can carry the system without losing too much of their original mission value. But if Elbit is right that the classic barriers of size, cooling, and stabilization have now been overcome, then Israel may do what larger powers talked about for years and never fully fielded. It may turn the airborne laser from a futuristic promise into a real combat tool. And if that happens, then the next revolution in fighter aviation will not begin with a new missile. It will begin with a beam of light.